Welcome to multiplication of single-digit numbers, part 2. This is Mathic, and in our videos we are on a mission to help you fear less, build confidence, solve problems. All by explaining fundamental principles of calculation so that you don't feel awkward whenever you need to deal with any numbers or numerical task. What is this guy talking about, you ask yourself? A lot of people hate math. It was never explained to them properly, so they don't understand it. And it cripples them in their day-to-day life. They feel stupid whenever they must deal with any calculation. Our mission is to change that, to help you fear less, build confidence, to equip you with problem-solving skills. Understand the basic calculation principles without memorizing complex formulas, and your life will change. In part 1 of the multiplication of single-digit numbers, we explain what the multiplication is and why is it helpful. We also explored 4 tools that will help us with multiplication. 10 by 10 visual table, different properties of numbers, thinking about money rather than numbers, and an imaginary line. I strongly recommend you going through part 1 video first, so that you have solid understanding of the basics upon which we will build now. Well, let's dive into the world of multiplication. We'll break it down step by step to make it easy to understand. Multiplication by 1 is super simple. When we multiply any number by 1, we just get the same number back. For example, 5 times 1 is just 5, and 10 times 1 is simply 10. Easy, right? Now let's talk about multiplication by 2. Think of it like making echoes of a number. When we multiply by 2, we are basically doubling the number. For instance, 3 times 2 is like saying 3 plus 3, or the number of squares in a 3 by 2 table. Similarly, 5 times 2 is 5 plus 5, which is the number of squares in a 5 by 2 area, but also the number of squares in the first row of our 10 by 10 table. If we calculate 6 times 2, we can count the number of squares in the 6 by 2 area, but we can also try to fill the result in the first row of our table. And as we will see, the numbers will not fit, so we will now exceed the first row of table. Only 4 from the second 6 will be in the first row, with the remaining 2 in the second row. In a similar way, 7 times 2 is the number of squares in the 7 by 2 area. Or we can place first 7 in the first row, add 3 from second 7 to fill remainder of first row, and place the remaining 4 into the second row. Same approach could be used for multiplication of 8 times 2. When multiplying 9 times 2, we can use a property of number 9 being 10 less 1. Thus do multiplication in 2 steps. Firstly, we will multiply 10 times 2, and secondly, we will subtract 1 times 2 to get the final result. Moving on to multiplication by 3. It's like a trio strike. When we multiply by 3, we are adding the number to itself 3 times. So 3 times 3 is 3 plus 3 plus 3, or the number of squares in the 3 by 3 area. When multiplying 6 times 3, we can count number of squares in the 6 by 3 area. Alternatively, we can leverage on property of number 6 being 3 plus 3. Thus, we can do the multiplication in 2 steps. Multiplying 3 times 3 firstly, and then adding 3 times 3 on top. 7 times 3, let's split 7 into 5 and 2 and do the multiplication in 2 steps, counting 5 times 3 first, and then adding 2 times 3 on top. 8 times 3, as 8 is 10 less 2, we can first count 10 times 3 and then subtract 2 times 3. 9 times 3, let's use the same approach, as 9 is 10 less 1. Let's multiply 10 times 3 first and then subtract 1 times 3 to get the final result. Now let's talk about multiplication by 4. We can split 4 into 2 plus 2, so we can use double multiplication by 2 whenever needed. For example, 4 times 4 is like saying 4 times 2 plus 4 times 2. Simple, right? 5 times 4, let's use the same approach. 6 times 4, we can split number 6 into 3 plus 3 and do the calculation in 2 steps. 3 times 4 plus 3 times 4. 7 times 4, it's easiest to split 4 into 2 plus 2 and sum 7 times 2 and 7 times 2. 8 times 4, let's use the same approach. Alternatively, we can use the property of number 8 being 10 less 2. We can multiply 10 times 4 first and then subtract 2 times 4 to get the final result. Similar approach could be used to multiplication of 9 times 4. Multiplying by 5 is a breeze because we have 5 fingers on our hand, so we can calculate on fingers. For instance, 3 times 5 is like counting the fingers on 3 hands. 5 times 5, we can use the same trick with hands, but we can also explore the different approach. As 5 is half of 10, in our 10 by 10 table, 5 times 5 is equal to 1/4 of the entire table. As number of squares in the entire table is 100, 1/4 is 100 divided by 4, and we get the final result. 6 times 5, why don't we split 6 into 2 plus 2 plus 2? We then multiply in 3 steps. 2 times 5 plus 2 times 5 plus 2 times 5. From our fingers exercise we know that 2 times 5 is 10, so 3 times 10 equals 30. 7 times 5, let's split 7 into 6 plus 1. We know the result of 6 times 5 from previous exercise. Let's just add one more 5 on top to get the final result. 8 times 5, let's split 8 into 2 plus 2 plus 2 plus 2. Thus we will calculate in 4 steps, adding 4 times result of 2 times 5. As 2 times 5 is number of fingers on our both hands, multiplying 4 times 10, we get to the final result of 40. 9 times 5, as 9 is 10 less 1, we can use two-step approach, multiplying 10 times 5 first and then subtracting 1 times 5 to get the final result of 45. As we are in the middle of multiplication, let's pause for a while and let's summarize what we have learned so far. There are 4 tools that can help us with multiplication: 10 by 10 table, different properties of numbers, thinking about money rather than numbers, and imaginary line. We have learned about multiplication by 1, 2, 3, 4, and 5, and please join me in multiplication by 6, 7, 8, and 9 in our next video.